All right. So week 2 is where we're at. And I think everybody did this. They completed the course readiness, so everyone has access to week 2 material. And the goal this week was to read through the module 2.2, bring it through 2.4. And do a couple, do the labs that were part of those modules. And then we have one lab assignment, 24110, which a couple of people did successfully. Just, so if you haven't looked at that assignment yet, you will have to read ahead in the curriculum to see how to use the input statement. Some of you, may have already done that or know how to do it, but I'll do that every once in a while. I'll have you do something in an assignment that we haven't really covered yet. And that's just because, once you're done with this class, if you want to continue programming in Python or anything else, you're going to have to mostly look stuff up and find out how to do things on your own. And so this was just an exercise to have you do that. Plus, I always like to take the lab assignments and add a little bit to them because the lab assignment on its own, you can usually, well, for those that haven't figured it out yet, go to one of them, 22111. Bring that up. Okay, so I'm not sure exactly what this one has you. It basically has you working with literal strings, but probably a few of you have already figured this out. Little tip icon down here gives you a little hint on how to do the lab, or at least get it started. And then sometimes, no, that one just doubled it. Oh no, yeah. So the first time you click it, it will usually give you a hint and get you started with the lab, and the second time it will essentially finish it for you. I'm not sure if all the tips completely finish it for you, but in any case, I want to usually add something to these labs when I make them assignments, so that you have more to do than what the little tip is going to show you. All right, let me get that out of here. Okay, and then by the end of the week, you want to do that Module 1 test. For the most part, I'll assign the test, the module test, not the quiz, but the module test, the same week that we finish the material. I gave you an extra week on this one just for people that are, a little bit behind getting started. After this, when we finish module 2, which will be next week, then you'll have the module 2 test at the end of next week. So in most cases, when we finish that module, whatever week that is, we'll also be doing that test. I just gave you an extra week on this first module test. Okay. Any questions on the material to cover and the assignments for this week before I get into the material itself? All right, so this is this part of the chapter, this part of the module deals with literals, and literals is essentially the data that's embedded in the program. And the example is, you know, a lot of what you've been doing so far. Strings. Strings are anytime you see any type of characters enclosed in quotation marks, that's a string literal. And then anytime you see a number not enclosed by quotation marks, that is a numeric literal. Could be an integer, could be a floating point number. So those are the two types of literals that you'll see. And the numeric literals can also, besides being decimal values, they can also be hexadecimal or octal or even binary, depending on how you express it. Okay, so it should be clear that these two statements, these two prints, while they produce identical output, they aren't the same. Anything enclosed in quotes is a string literal, and you can't do arithmetic functions on it. For example, let me bring up Fawny, the Fawny console. Okay, so it sort of did an arithmetic function on it, but not what you would have expected if it was a numeric literal. It basically, the plus sign between the two quoted twos is a concatenator. It just puts the two strings together and then creates a single string from the two. Whereas obviously if I did 2 plus 2 without the quotes, you'd get the desired effect. Now, strings can't use all of the operators. Okay, that doesn't work. A minus sign is not a valid operator on a string. However, there is a, this is a little bit peculiar to Python. You might see it in other languages, but not too many that I'm familiar with anyway. You can, besides using the plus sign to concatenate strings together, in other words, take multiple strings and create one string from them, you can use the multiplier operator to essentially just duplicate the string, right? So doing quote 2 times 3 just duplicated the 2 3 times. Same thing, any string I do will do the same thing, all right? So that's the exception as far as string literals not using arithmetic operators. They use arithmetic operators, just not in a math function, more like in just a putting strings together. All right. Okay, so two different things. They produce the same output, but in this case, they produce the same output, but they're not identical. All right, literal integers. Basically, you have two numeric types in Python, integers and floating point numbers. And a floating point number is just any, if you write a numeric literal with a decimal point, a dot, it will become a floating point. So let me show you that, demonstrate that. Bring Thorny up here. By the way, you haven't figured out already, if you're using Thorny and you want to clear the console, just Control L, and that clears your console. Okay, so the number 4 is an integer. How do I know it's an integer? Well, here's a little function that you can use at the console of Python. The word type, or the function type, will tell me what type of value that 4 is. And it says it's a integer. Class int means it's a of class integer. Whereas if I say class string, if I say just put a dot after the 4, it's class floating point. Same thing if you put the dot before the number, obviously. It's the value 0.4, but it's still a floating point. Okay, so if you want to use something besides decimal, decimal numbers are the default type of integer in Python. If you wanted to use hexadecimal, you put 0x in front of it. That's pretty much the universal nomenclature for hexadecimal. So hex 5e. Now what it's going to do, what Python's going to do is it's going to turn that into the decimal equivalent. So what it'll print out is the decimal equivalent of 5e, which I believe is 94. And you can also do octal, which is 0o. Yeah, 0 and then lowercase o. And that'll give me the decimal equivalent of octal 466. Okay, so besides, decimal is the default, but if you want, for some reason, to express your numbers in your program using literals as hex or octal, you can do that. You can also do binary, I think. Yeah. So 0b, and then followed by a string of 1s and 0s, will give you the decimal equivalent of whatever that binary number is. All right, so pretty handy, especially when you're dealing with a lot of binary numbers. You can use Python essentially as a quick calculator for certain things. Okay, and this page here just talks a little bit more about how numbers are expressed. You can't use commas, or in Europe they use dots to group your powers of 10 together. You can, however, starting with Python 3.6, to make your code a little bit more readable, if you've got a literal value in your program that's a really long number, like this string of 1s, you have to look at it and say, well, what is that exactly? 3, so it's 11,111,111. So it's a little bit hard to read. In Python 3.6 and above, and we're using 3.8 or 3.9, depending what you install, you can use underscores to separate the group, to do the thousands or powers, the powers of 10 to the third groupings. Okay, positive numbers, you can put a plus in front of a positive number if you really want to, but by default they're positive. You can put a minus sign in front of a number to make it negative. Okay, this talks about the hex and octal, which I just went over, and then floating point again, you just include a dot to show that it's a floating point number. Now, Python will also, if it's a really big number, it will put the number in scientific notation. And sometimes it'll do that for you. So if you try to print, I think, we can try it. I'm not sure exactly what the cutoff is as to where it decides to put it into scientific notation. So this might do it since it's in the example. I kind of think it might. Yeah, so it didn't put it in scientific notation, but I think if you make a number big enough, Python will automatically turn it in scientific notation. I don't know where that cutoff is. I thought it would do it by now. Maybe this version of Python doesn't automatically do it. I know I've seen it before.
In Thani, can you press up to repeat the last command?
Yes. Just do that. Press the up arrow to repeat the last command. Yep. Repeat them successively. Yeah, and that happens in the standard Python console too. You can use the up arrow to repeat the previous commands. Okay. We don't deal a lot with big numbers in this class. We don't do a lot of heavy math oriented programming at all. But you might end up doing that at some point. So it's good to know how to use scientific notation because it is a little bit easier to write when you get into some really big numbers. So let me go back to strings. Okay, so this is this a little bit about strings. Might have already come across. There was the lab that I had you do, had you add quotes to the output. And in order to do so, there was a couple ways that you could do it. And this page kind of demonstrates the two ways. One is by using the backslash and what's called escaping the quotation. When you put inside a string that uses double quotes, if you escape the character, in other words, backslash is the escape, the indicator that it's an escape character, it will literally print that character. Or in some cases, it does special things like /n will print a carriage return line feed. But for the purposes of what that one assignment had you do, which most of you did just fine, a couple people struggled with getting the quotes out there. This is one way to do it, and the other way to do it is to use single quotes and put the double quote inside the single quote. Okay, so if you start your quote with single quotes, you can put double quotes inside of that string. If you start your quote with double quotes, you can put single quotes inside of the string, or you can escape it. So I'll show you the two ways to do this for those that haven't already come across it. All right, so this one is going to use the escape version, and then I can also enclose in single quotes, and then I don't have to escape the character. I still could, but there's no reason to. Since I'm enclosing the whole thing in single quotes, then my double quotes will print. And vice versa. I could also print single quotes by enclosing everything in double quotes. Okay, so just a little bit of printing peculiarities that you need to know. Let's see what else on this page. There's such thing as an empty string. So just double quotes together or single quotes together will create a string, but it will be empty. So you may wonder what the use of that is. And right now it's really be difficult to explain it. But basically, if you want to initialize a variable to a particular type, make it a string, you could give it an empty string to begin with. So here's my string using double quotes or single quotes. Now, you type string, it says it's a string. Okay, so where might you use that? Well, let's say if you had a program that was going to build a string from some sort of input. You would do something like this. Well, let me do it. Let me make it so it'll cause an error first. So if I did my string equal my string plus hello, or whatever, it doesn't matter. This isn't going to work, okay? That's because my string doesn't exist yet. I haven't created it. And whenever you reference a variable on the right side of an equal sign, or in any other way, when you reference that variable, it has to exist before you can, essentially before you can use it. So if I wanted to actually make this work, and I wanted my string to just contain the word hello, I would first have to make it a blank. Now I can add hello to it, and you'll see my string is equal to hello. And then I could keep on adding stuff. That's why I was saying if you wanted to build a string from a series of strings. And then now my string equals hello there. Okay. All right, that would be one reason why you would want to use double quotes to initialize a string. There might be some other reasons, but typically it would be to initialize a variable as a type string if you're going to be using it elsewhere. Okay, now we come to Booleans. Booleans are true or false in Python. They also have essentially the value 1 or 0. And to demonstrate that, we'll first look at printing or let's say, we don't really need to print here. We can just say, true and false are keywords in Python. So they have to match the keyword exactly, the capitalization. So you have to use a capital T to denote true and a capital F in false. So first off, if I say true equals false, this is the double equal sign is basically asking, is true equal to false? And of course, it's going to say no, or the result is false. Now, can I say true greater than false? Well, in that case, it's true because as false greater than true is false. Okay, so that's because when it gets down to the actual innards of the computer code that's generated from the true and false values, they're really just values 1 and 0. Python, if you create a variable with true, with the keyword true, or assign it to the keyword true, or assign it to the keyword false, then it'll always print it out as true or false. but you can also compare them if you wanted to for some reason. Not too many reasons to do that, but it could come up. Another thing you can do, of course, is assign a variable to a comparison, like x equal 2 greater than 1. So what do you think the value of x is going to be in this case? I just assigned a variable x to the results of 2 greater than 1. What do you think x is going to be? Anybody? Do you think it'll be a number? Will it be a numeric value? Will it be a string? No, we'll just see. X is true. Okay, so whenever you do a comparison, we'll get into this later on. Whenever you do a comparison between, a comparison becomes a Boolean value. The output, or the results, I should say, of a comparison is a Boolean value. If I said x equal 2 equal 2, now x is going to be also true. If I said x equals 2 less than 1, x is going to be, of course, false, because 2 is not less than 1. Okay, so Booleans are something that you'll use quite a bit in programming. Mostly they'll be used when you're testing some sort of condition to decide whether to execute a block of code, like in an if statement or in a for loop or something like that. But you'll see Booleans used quite a bit as you program more. All right, and so that was that one of that first lab. I'm going to skip that for now. And there's the section summary of 2.2. To make sure that you understand a section that has just been gone over, a lot of the summaries, the section summaries, have this key takeaways section, and there's little, check your knowledge exercises. So to make sure that you understand most of the concepts that were talked about in that section, you should do these and click the check button to see if you were right. So we know that these two are both going to be strings, and that's what they produce. What types of literals are the following? So we've got a string, a float, an integer, and a Boolean. And the decimal value of the binary number, hopefully you can do binary to decimal conversion. If not, you just let Python do it by, if you wanted Python to show you what the decimal value of that is, what would you do in the console? So if I want to find out what 1011 is, if I just say 1011, it's just going to assume I mean a decimal number, 1011. If I want to know what the binary 1011 is in decimal, what would I do?
0B.
Right. And it gives you 11. It's not 11, it's 11. That's a bad example. So let me do it with a different string. Okay, that's going to give me 15. Okay. Let's move on to the next section, operators. The operators, most of these operators you will have you'll have seen in just arithmetic, plus, minus, the asterisk for multiplication, the slash for division. But there's a couple that might be a little bit new. Here are the most common operators here: plus, minus, multiplication, division. And does anyone know what the double slash is? Anyone know what the double slash is? It's a type of division. It's just that it's integer division. Generally, a single slash indicating division always produces a floating point number, floating point result. Even if you've got two integer values, if you try to divide, let's say 4 divided by 2, and I'm gonna, well, we know what the result is. It's 2, but it's 2.0, indicating that it's a floating point. If I do the same thing, 4 divided by 2 with the double slash, it basically lops off the floating point part. So let's do that again with something that will produce something besides 0 after the dot, 1.66666. So what if I did that? What do you think that's going to produce?
One remainder 666.
So it's just going to produce
Something.
1. It essentially, when you do integer division, it just basically lops off the entire rest of the value after the point, after the dot. And
Round it?
it doesn't round it. Nope. If you want a rounded number, there's a function to round, but it does not round by default. When you use integer division, actually, I don't even think you can round in. I think actually, I haven't tried to round a integer division result. But anyway, so remember that integer division just lops off everything to the right of the decimal point and stores the result in an integer variable, or just an integer literal in this case. So that's integer division. The other one that you may not be familiar with is the percent. Anyone know what the percent is? Okay, the percent is not something you see in math very much. It's called a modulo, and it produces a integer remainder. So five module 3, it's basically like doing the division and then saying what the remainder would be. So the division, 3 goes into 5 one time. The remainder is 2. So modulo will just give you the remainder. So it gives you 2. What will 17 modulo 6 give you?
5.
5, right. Goes in twice to 17 and with 5 left over. So that's what modulo does. Modulo is a really nice operator, something that if you do enough program, you'll end up using quite a bit. I'll give you an example shortly, besides, just doing some simple, besides showing you what it does, I'll give you a real world example. And then the double asterisk is the power of. So when you use double asterisk, it's like raising the number to that power. So 2 asterisk 4 is 2 to the 4th power, which, anyone know what that is off the top of your head? 2 times 2 times 2 times 2. You've forgotten your binary arithmetic. 2 to the 4th is 16. All right, so that's those other operators. And again, if you are a little unclear on all this, do some of the examples. Just that's what they're here for. You just copy do, select Control C, paste, and then run to see the examples. Again, this is showing that the division operator always produces a floating point, even if both values are integers. All right, let me go in here. All right, so this is talking about modulo, which I've already looked at. We've already looked at. So in this case, just showing you another example, 12 mod 4.5. So seeing what it does is nice, but how about an actual example? An actual example of using modulo that you might actually use in a program. First one to look at would be, how about if I wanted to, here I'm gonna, this will be an example of using integer division and modulo. How many hours, minutes are there in 339 minutes? Okay, so the way that you would work that out okay. So we want to find out how many hours, minutes there are in 339 minutes. So I'm going to use a variable here. You wouldn't have to use a variable. You could do everything with literals, but you're going to be, you're going to be using variables quite a bit, so might as well get some practice. So first off, I want to assign the number of minutes to the number or hours, the hours variable to how many hours 339 minutes works out to. So how would I figure out how many hours are in 339 minutes?
Divide by 60.
Right, there's 60 minutes an hour, so you divide by 60. Now, if I use integer division, I end up with a floating point number. And that's not what I want, because I want to express it in hours, minutes. And no one really expresses hours as a floating point number. So instead, I would use integer division to lop off the decimal part of or the part after the decimal point. So now hours is just going to equal 5, right? And now to get minutes, so how many minutes are there remaining after the 5 hours? How many minutes are there left? Well, you could do it in your head and say 60 goes into 339 5 times with 39 left over. And that's what the modulo is for. So 339 modulo 60 will give you that remainder. So after you get those two values in a variable, then in a real program, you would probably print that out. 5 hours and 39 minutes. Now, what I just introduced here is something that I don't think we've seen yet, but what that is doing, str in front of the variable hours, it's creating, since hours is a integer value, and I'm using the concatenation operator here, I need it to be a string, because I want to take my variable hours, put a colon, and then add my variable minutes to the string. So there's other ways I could do this, but the probably most straightforward way is to use the string function on hours and minutes, and what these produce are the string version of 5 or the string version of 39. If I left those off, I just said, hey, I want to add hours, put a colon in it, and then minutes, it's not going to like that because the concatenation operator, the plus sign here, being used with the colon, the string colon, it expects a string on both sides of the plus sign. So you have to convert that to a string first. Okay. Okay, and then you know what the plus and minus are. They add or they subtract, and you can use the minus operator as a unary operator, which means you're making the number negative, as opposed to using it as a binary operator. Binary operators work on two values, one on the left and one on the right. Unary operators just work on a single value. So you won't see the plus as a unary operator very often, just because by default numbers without any sign in front of them are automatically positive. So you don't usually want to use it unless you have a particular reason to use it. Okay, so bindings of operators. So just like in real math, you need to know the precedence. What operator, when you've got a long string of information, which operation comes first. And to do an example of that, we'll look at this modulo. So 15 mod 8 mod 4 is going to give you what result? Does anyone know?
3.
3, exactly. So when you've got a string of operators and there's nothing to change the priority, then you just do them left to right if they're of equal priority. And modulo, of course, is equal to itself. So you'd say, in order to figure this out, you'd say 15 mod 8, and 8 goes into 15 once with the remainder of 7, and then you'd say that take that result and mod it by 4. So you end up with mod 8 is 7, and then 7 mod 4 is 3. Now, if I wanted to change that, if I really meant 15 mod 8 mod 4, if I really wanted the 8 mod 4 to happen first, then I would put parentheses around the 8 mod 4. So now 15 mod and then 8 mod 4 gets calculated before the 15 mod gets calculated. So 8 mod 4 will be 8 mod 4. 4 goes into 8 2 times, remainder 0. 15 mod 0, 0 goes into 15. Well, you can't do a mod by 0. So that's the lesson there. Since 8 mod 4 is going to equal 0 because 4 goes into 8 evenly with 0 remaining, you, just like you can't divide by 0, you can't modulo by 0. All right. Let's look at another one. The exception to doing the calculation left to right is when you have exponents. When you have exponents, you do the right and if they're not enclosed in any parentheses or anything, you do the rightmost exponent calculation first and then move to the left. So that's the exception with the left to right rule when all of the operators are of equal priority. So in this case, you will do the 2 raised to the 4th, which is 16. And then you will do, so you'll do this calculation first, 2 to the 4th is 16. Then you'll do 2 to the result of 2 to the 4th, which, so you'll do 2 to the 16th, which will end up as 256 or 65535. So it's basically the same as doing 2 to the 16th, because that 2 to the 4th got done first. Okay, if I wanted the 2 squared to happen first, then I would just do now it'll do 2 to the 2 squared, which is 4, and then raise that to the 4th, which is going to be 256. All right. So you use parentheses to change the default binding, as they refer to it, or default priority of the operators. All right, so we just did that, or something like it anyway. Okay, so remember this list. Unary operators are have the highest priority, so you won't, like I said, you won't see a plus unary operator used much, but you will see the minus if you're dealing with, negative numbers. And then exponentiation is the next highest binding or highest priority. Then all of these are the same. So if there's no parentheses in the equation, they just get left to right with no priority, essentially. And then finally, the binary plus and minus operators are last. So they get done last. So basically, let's look at this example here. So you have to take a look at this and say, okay, what am I doing first? Well, you've got this inner parenthesis. You've got this whole thing enclosed by parentheses. And then you've got this enclosed by parentheses and that enclosed by parentheses. So we basically, we look at this inner part first, since that's what's happening first, because they're enclosed in parentheses. That makes them the highest binding. So we do that 5 plus 3, which is 8 mod 3, which will end up as 2, because 3 goes into 8 twice with 2 remainder, divided by 8. So what this ends up to be is really 4 times 2 divided by 8 times 4, because this whole thing right here evaluates to 2 divided by 8. And then we've got the 2 multiplications on either side. Both give the same result. And it's a floating point result because there was a floating point division as part of it. Whenever there's floating point division, or if any of the values are floating point, then the result is going to be floating point. All right. It's just, brings you back to your 6th or 7th grade math, where you had to go and figure out all the priorities and pull your hair out trying when there's gets to be a lot of parentheses in an equation is when it starts to get really ugly and difficult. But I would go over this little example and make sure that you can get it right. If you can, before you click on check, then you probably understand not only priorities, but also modulo and integer division. All right, and that brings us to the summary. So again, to check your learning, make sure that you can do those. I'm going to give you just a few minutes and see if you can come up with a program. Okay, I gave you an example of how to figure out hours and minutes based on the number of minutes. So what I want you to do instead is calculate the number of years and days given a number of days, and then print the days like so. Get that board. So using, let's say, 500 as an example, give you a minute or two to see if you can come up with the proper way to express a number of days using 500 as the example as years, X years, comma, Y days, where X and Y are the number of years and the number of days. And if you get that, basically you could do it in one print statement without using variables, or you could use variables and 3 variable assignments and also one print statement. You don't have to use variables to do something like this, but in real life, you would almost always use variables if you were going to use this beyond just an example. I'll be right back, and then we'll see if anyone's got a solution. Okay, anybody have a solution to that? If you do, just tell me what I should start typing.
Years equals 500 / 365. And then days equals 500 modulo 365. And then print string years plus colon plus string days.
Let's see. We're going to print the value of the years first. So is that what you said? I'm sorry. You might have. So say it again. Is it Cody? Yeah. Say it again. Or did you do it differently?
I think I did it a little different.
Okay. So what was your solution?
It was pretty much the same as what you did for the last one.
Oh, okay. Like years.
Yeah.
Like that?
It was the print string years.
Oh, you
plus,
converted
that
years to string.
one.
Okay. In this particular case, I'm not. Well, yeah, you might as well do it. You wouldn't have to, but yeah. So like that. Except you were doing a plus, right? Right. And then what? Cody.
I'm gonna copy and paste it in the chat.
Oh, okay.
Yeah. I just kind of copied what you did last time.
Oh, Oh, okay, you did it with a colon, all right. All right. 1 year, 135 days. And one thing when you're doing any assignment, since this is just an example, it's fine that you deviated from the instructions on how it should look. But when you are doing a assignment that you turn in, make sure that it's very important to get the output format the way that the assignment requires, because just like if you were doing a programming job for somebody, they're going to want the output to look the way they want it to look. So if I was trying to get it to print like this, X years, comma, Y days, I would do something pretty similar to what you did. I would just do it like years, so X years. What did I do wrong here? Oh, I've got Microsoft curly quotes. Cutting and pasting from Microsoft applications that automatically change your straight quotes to curly quotes doesn't work. That's why it was complaining. Okay, so same result, just different way to express it. All right. Variables. And I think that's the last topic for the week, so it'll be the last topic for tonight. We've been on for about an hour, and so I don't think we won't go any beyond 2.4, and if it takes a while, then we may end a little bit early. Okay, so variables in Python, it's pretty flexible what you can use for variable names here. All of these examples are good. So they can be a single letter. They can be a letter followed by a number. They can be words separated by underscores. However you want to do it. You can't have a variable start with a number. You can use language-specific notation. Some of the language-specific characters you can use. But again, you can't use a variable name that starts with a number, and certainly no spaces. Okay, and Python has a style guide that basically says, here's what we who wrote Python or some committee just think that this is the way we think you should name your variables and other things like functions that you might write. These are not something that you have to follow, and frankly, I don't follow them much because I programmed for so many years before I learned Python that I just had my own kind of standard, even though I don't always follow it, but sort of my own standard for using variable names and function names. So this is what Python says you should do, either just a lowercase word or two words separated by an underscore. Same thing with function names. Okay, so that's the official PEP 8 style guide, but they also say it's okay to use mixed case. So instead of my underscore variable, everything lowercase, starting with lowercase and then the next word starting with capital letter, so it's still readable, is acceptable, they say, as long as it's because you've already started the program like that. I tend to go with this style myself, just because that's the way I learned it. But I think if you're learning Python, if it's the first language you're learning, I know some of you have already been, using other languages, and so it might be harder to remember the style guide. But those that are just learning Python as the first language that they've ever done any work in, you might as well start off using the PEP 8 style guide, which means lowercase or lowercase, always lowercase. And if it's something where you want to be very descriptive, 2 words, 2 or more words separated by underscores. You can't use keywords as variable names. So these are all keywords in Python. There's probably others. Okay, so all of these words that you see up here are part of the Python language. Okay, we already saw false and true. We haven't seen none yet. It's part of the language. And all these others are part of the language, and you can't use those as variable names. You can you can use a keyword if you use a different capitalization, but it's certainly not recommended. In other words, you could use, and the example they gave is the import statement, you could use capital I to differentiate it from lowercase, and it will allow you to use that as a variable name. But I don't recommend doing that just because it's confusing. Hey, and how do you create a variable? You just assign it to a value. That's how variables are created in Python. Other languages, I think somebody said they learned C++ or C#, require you to declare the variable, meaning you need to say this variable is of type integer, or this variable is of type character, or floating point, or whatever. Python doesn't have that. There are extensions to Python, well, in later versions of Python, where they've got something called type hints that can be used in function declarations, but we're not going to talk about that. May not even get to that at all in this course. So basically, when you assign a variable a value, you're creating that variable.
Okay, so it automatically figures out what type of variable it is then, right?
Based on the value that you assigned it. The other thing is,
Okay.
if you use the same variable and assign it an integer, so it's of type. Okay, it's integer, but now I can take that same variable and say assign it to something else, and now it's a string. So if you that doesn't work in other languages. Other languages would say, hey, this is an integer, you can't assign a string to it. In Python, when you assign a variable a value, it essentially, every time you make an assignment, it recreates that variable. And so that means you can change it from one type to another just by doing a new assignment.
How would you go about pre-declaring a variable then?
You don't pre-declare it as a well, you could pre-declare a variable like I showed you before by just assigning it a value. So I could say this, or my string equal empty quotes, and that automatically creates an empty string. Or I could say my list, which we haven't gotten into yet, but we're going to talk about lists. My list equal left bracket, right bracket, that creates an empty list. So there is a need to do that in some cases, especially with lists. If you're going to build a list within your program, build it on the fly, you might need to create the list empty first, and then you can append to that list within your program. You couldn't, well, let me just do this. A list I didn't create a variable called a list. So when I try to append to that, it's going to give me an error. If I wanted to append to that, I would have to first create it. And then I could say, now it's good. Now if I say what's the contents of a list, the first statement just made an empty list. The second statement, the append, appended an item to that list, which is a string item. All right, and then I can do that again. And I can even append something different, a numeric value. Now I've got a list of 2 items. One's a string and one's a numeric value. Okay, but we'll get into lists. Actually, we'll take quite a bit of time when we talk about lists a little bit later. But lists are one of the key data types within Python that are frequently used, sort of like arrays in C# or C++.
So
Okay.
when you're creating like a code in Python, I guess that's going to be a big change from C# because C# typically you make all your variables up at the top of the code, and then you use them later on in the code. But
yep,
you don't really pre-declare here, do you? You just kind of make them on the fly.
Nope, that's exactly right. Now, what some Python programmers will do is they'll put up in the comments, you know, what this is a comment, a Python comment, the triple quotes, and then end triple quotes. So I can put in, you know, anything I want here, and Python will just ignore it if I try to run this. So what some people will do is put up in the comments of their program all the variable names and what their function is and what their type is. But you know, there's no, it's not actually declaring them. It's just documentation. And so, yeah, I would recommend doing something like that, especially in a long program that, you know, might go on for pages and pages. You might, you know, for anybody, including yourself, that looks at the program weeks or months or years later, having that upfront documentation saying what all the variables purposes are and what types they are would probably be, you know, a useful thing, but it's not something that you have to do in Python. You don't have to declare them at all. Okay. So if you look at this example, it's assigning 1 to the variable var, printing it, and then this statement here, var equal var plus 1, what's that is doing, it's taking the value of var, adding 1 to it, and then essentially recreating a variable called var and stuffing the result of 1 plus 1 into it. Okay, so in reality, that var and that var are actually 2 different, potentially, even potentially taking up 2 different places in memory within Python. Yeah, Python's, you know, definitely different. That's mostly because compared to C++ or C#, it's a interpreted language versus a compiled language. Compiled languages have to have a lot more stuff declared up front, like the variable types. And interpreted languages are a lot more flexible in that regard.
I have one last question. So in C#, if you did like var equals, you could just do plus 1, and then that would automatically do the whole var plus 1 instead of having to type out the name again. Is there a thing you do in that, or is it always just
no, in C#
var plus 1?
In C sharp, you could say, let's say var equals 0, and then you could say var plus plus, and that will increment var, and it'll have the value 1, correct?
Well, you do var equals plus plus 1.
No, not that, no.
Yeah.
No. In C?
Yeah. C sharp. Not sure how it varies across the other languages.
Really? What? Oh, okay. Really? That's weird. I never saw that. Well, in C or in even C++, var plus plus will increment whatever the value of var is right now. It'll equal 1 more. The way that you do that, the shortcut way that you do that in Python is plus equal. So now var equal 1. It's not that much different. It just is, it's var plus equal 1 versus var equal var plus 1. It saves you just retyping the variable name, which is
Right,
similar
okay.
to what C
So
sharp.
probably that's the Python equivalent of it. Cool.
Yeah.
Sorry, I'm trying to grip my head around it.
I think we look at that. I don't think that we've come across that yet in the curriculum, but we do come across that shortcut nomenclature at some point. So it's just a shortcut. This right here is identical to this. And of course you can do something besides 1. Plus equals 15. No, it's equal to 17. All right. Okay, so let me catch up in my notes here. This isn't too important for me, but if anyone that likes to, that's a math person and might do some scientific programming, some math programming, the way that you do a square root in Python, and this is similar to most other languages, is you raise it to the power of 0.5. So raising something to the power of 0.5 is the same as square root. So 4 raised to the power of 0.5 would be 4 square root of 4, which would be 2. But again, math isn't a major part of the course. I do expect you to, get all the what the basic function is of all the operators and the priorities of the operators. But we don't do a lot of heavy math in this class. All right, let me see where else. Okay, yeah, shortcut expressions are coming up here. Yeah, shortcut operators, what I just said. You can use shortcut operations with the plus, with the multiplication, and the division, even the modulo. So just remember that if you see it, it's simply shorthand. It's not doing anything different. These two are, that statement and that statement are functionally equivalent. Okay, can even do it with raising to a power something. I don't recommend getting, getting too crazy with shortcut operators because it can make the code a little bit harder to read at cases, in certain cases, but you have to decide what makes the most sense for you. All right, let me see. Okay, so these are the labs at the end of the module, and this is the one that I have you do as an assignment. And in the assignment, you basically, write the necessary code, and it tells you what to do over here. You basically duplicate this equation using Python code. But in my assignment, instead of hard coding your data, you're getting that data from an input statement. And the input statement is a little bit further along in this section. I think maybe 2.6. Yeah, 2.6, the input function. So in order to do this, just go find out how to use that input function. All right, I think that is it for 2.4. Yep, there's a section summary. Again, make sure that you understand and can, work all these out in your head or on a piece of paper, whatever you need, and then check your works. And if you can do all that, then you understood the section pretty good. 2.5 is a real short section. I'm not going to bother going over it because it's really just telling you about using comments in your program. The primary way to do comments in Python, single line comments or end of line comments, is the pound sign. Okay, so the pound sign can either be, say, create a whole line comment if it's the first character in the line, or you can use it at the end of a line to describe what that particular line of code is doing. All right, so anything that comes after the pound sign is ignored by the interpreter. It's just for us humans to see and to get more information about what the program's doing. The other way to do comments, see if they do it. Yeah, they didn't talk about the other comment, which is the triple. If you want to do multi-line comments without having to put a pound sign in front of each line, then you use triple quotes to start the comment. Write your comment, and it can be as many lines as you want as long as you end with triple quotes. Everything between the triple quotes is ignored by Python. Okay. This actually allows you to not only create a multi-line comment, but it actually lets you make a multi-line string as well. So if I wanted to, and I think this is discussed somewhere down the road in the curriculum, I could actually assign to a variable this triple quote, and it would look exactly how it's shown here. Everything between the triple quotes would be assigned to the variable x. The only reason to do that, and I use it, I think, in one assignment that I give you, where I give you a big paragraph, and you have to do some sort of manipulation, maybe count the number of words or count the number of times a particular word is used in that paragraph, something like that. So it's got the triple quote has two purposes: to make multi-line comments and to make multi-line strings, string literals. All right, so we're on to 2.6, which is actually, I believe that's topic for next week. Yeah, we only go through 2.4, so just a real quick comment before I let you go about next week. I have published it. I might still make a couple changes, but here's where I'm going to have you kind of work ahead, because in my opinion, they talked a lot about strings in the first couple of modules of this Python curriculum, but then they don't really tell you a lot about all the functions and what they call methods that you can do with strings. And I'm going to have you do some assignments that require that you know all of these, what they are referred to as string methods. I'll give you an example real quick, but basically you're going to have to skip to module 5, which is actually in, later on in the course. Let me get back into, it's under the Python Essentials Part 2 Intermediate. So next week, I want you to go, 2.5 through 2.6. Then I want you to go and look at those string methods. All right. And I showed you the one, the type console function that can tell you the type of a variable or a literal. The other one is dir. I'll probably go over this next Wednesday as well, but just to give you a heads up, what the dir console function does is it tells you the possible methods that are available for a type of value. So if I say dir double quotes it just means it's a string, it's an empty string. Well, by sending that to the dir function, I'm asking Python, what are the possible attributes and methods available for strings? And it gives me this big list. And just real quick to show you an example of using one of the methods, I'll use the upper method. And I'll say x equal so if I show x, it shows exactly what I did there. Now if I say x dot upper, okay, the way that methods are called is you type the variable name, or you can even use it on literals, and then a dot and then the name of the method. Some methods have arguments or parameters that you have to send them. The upper doesn't, because it does something really simple. Upper just converts the case to uppercase. All right. So it took my X string and it produced the uppercase version of that X string. It didn't change X. Notice, it just produced a string, returned a string that's all uppercase. If I wanted to change X, I'd have to say X equals X dot upper. And I have to assign the output or the results of the upper method back to X. Now X equals the uppercase version of my hello there string. Okay, so that's just an example of how of using a method and one of the methods. The ones I want you to take a look at are the len is really a function, not a method. I really shouldn't have it in here. I don't think it's a method. Yeah, len is a function, so I can say len x. And it tells me how long of the string is. It's 11 characters long. But all the others are methods, which means that you use them just the way I did this upper. So I'll use the replace one just as an example. X dot replace okay, so everywhere HE was found in my string hello there, it replaced it with she. So it's now Shalot share. Okay, so a trivial example of using it, but replace obviously is something that you could find uses for in an actual program. So the curriculum has details on each of these, and I tell you where to find those details and the module. So you have to go all the way back to the, the start of the course and find module 5. And I have to re-log in. It logged me out. But anyway, if it hadn't logged me out, that would take me to module 5 and just find where each of those is described. All right. All right, any questions? And you've got a bunch of assignments to do, some lab assignments. These 2 are not published. You don't see these yet, but I will be publishing another assignment, maybe just 1, maybe 2. And then these here are things that I want to try to do at least some of them in Wednesday's Zoom. So doing these will depend on you getting through most of this, the rest of this material, the rest of module 2, and looking up this information. Okay. All right, anything else before we go?
Is our meet time at 7 now?
Okay, I tried. One person cannot make it at 7 at earlier, except 15 minutes earlier. So I'm going to change it to 7:30. I'll take a little bit earlier if I can get it. Everybody else that responded to the question said they could do it at 7 or 7:45, but one person apparently has something going on and can't make it till 7:30. So I'm going to change all of these to 7:30. It's a little bit better than 7:45, I guess, but I couldn't get it as early as 7, unfortunately. So yeah, I'll change that meeting time, and I'll send out a new announcement saying that we're going to be meeting on Wednesdays at 7:30 instead of 7:45. Okay, that works for everybody, right?
Thank you.
Okay. Yeah, I wish I could get it earlier. Trust me. Because I can't do this at home. I got to be here with all my screens because I usually set stuff up with, a screen here and a screen there so I can just pull them up real quick. I could never do that on my laptop at home. So 7:30 it will be. All right. We will see you next week. Let me know if you have any questions. Send me an email or whatever. All right. And this is recording, so I'll be publishing that recording just as soon as I get it. Okay. All right. See you around.
You're well.